Am I audible?
Yes, sir.
Okay. So this is the revision class for Unit 1. We will discuss a few problems in eigenvalue vectors and few short questions and long questions based on that eigenvalue eigenvector. First, one small recap for this: what is mean by the eigenvalue eigenvector. We express, let A be the square matrix of order n, then X is the, if any doubt is there, you can stop me in middle, you can ask the doubt. X is the non-zero column vector. Or
So,
let,
are you sharing the screen?
yes,
So, are you sharing the screen?
yeah, just wait, I'll share that. Yeah, I didn't share, I'll share it now. Visible?
Yes, sir.
Okay, fine. So here with the square matrix of order n, X is the non-zero column vector. Then if you are multiply that A and X, you will get that lambda X. I think somebody's want to join here. In case if anybody is enter, you can admit them. Any one of them can admit them. Possible, no? Okay. So Ax equal to lambda x here, where x is known as the eigenvalue. Then this lambda is the, this is known as eigenvector. The process of finding the eigenvalue eigenvector is, if Ax can be expressed as lambda x, if you are able to write that, otherwise just you follow that, afterwards you can write. Okay, so Ax equal to lambda x, that implies Ax minus lambda I into x equal to 0. If I take that x outside, then a minus lambda I into x equal to 0. Then the determinant of a minus lambda I equal to 0 gives the characteristic equation. Then solving characteristic equation, we get eigenvalues lambda 1, lambda 2, lambda n, and then I think few of them having still doubt finding that eigenvalue eigenvector. Actually, I have explained two methods. One is synthetic division method, otherwise trial and error method or substitution method. Okay, so after finding that eigenvalue lambda 1, lambda 2, lambda n, then for each value of lambda, for each value of lambda, we can find the set of vectors x1, x2, xn. It is called eigenvectors. Okay, this is the definition actually. So from this, just first we have to find that characteristic equation. Afterwards, you have to find that the eigenvalues. This is the procedure. First you have to find that characteristic equation a minus lambda I equal to 0, and then you can find that the eigenvalues lambda 1, lambda 2, lambda n. From that lambda 1, lambda 2, lambda n, we can find that the eigenvectors x1, x2, xn. Okay, fine. Particularly, what are the properties of eigenvalues? Very simple. Just with a quick recap, we can do that. Properties of eigenvalues. First property is A and A transpose have same eigenvalues. Second one property is that sum of all the eigenvalues equal to sum of diagonal elements of A. This is second property. Third property is that the product of all the eigenvalues is equal to determinant of A. Okay, then the fourth one is if lambda 1, lambda 2, lambda n are the eigenvalues of A, then k lambda 1, k lambda 2, k lambda n are the eigenvalues of Ka, lambda 1 power p, lambda 2 power p, lambda n power p are the eigenvalues of A power p. Third one is 1 by lambda 1, 1 by lambda 2, 1 by lambda n are the eigenvalues of 1 by A. So these are very important properties. From the based on the properties of eigenvalue, compulsory one problem will come. And then one more property, very important property is that in case the given matrix is the triangular matrix, that means the eigenvalues of, not fourth one, it is the fifth one property, the eigenvalues of a triangular matrix. See, triangular matrix is that either it is the upper triangular matrix or lower triangular matrix. are just the diagonal elements are just the diagonal elements of A. See, for example, if A equal to 1 0 0 2, it is a diagonal matrix. Other than diagonal matrix are other than elements of the diagonal is 0, only diagonal elements are there, then the eigenvalues are lambda 1 equal to 1, lambda 2 equal. In case if it is upper triangular matrix, what is meant by upper triangular? Below the diagonal elements, all the elements are 0. For example, here 1 2 3 is there, 0 2 3 is there, 0 0 3 is there. If it is the matrix, see here below the diagonal all the elements are 0 here. So that means below the diagonal, this is the below the diagonal, all the elements are 0 here. Therefore, it is known as that upper triangular matrix. Here the eigenvalues are the same thing we can follow for that lower triangular matrix. Eigenvalues are 1 2 and 3. So no need to write anything, just these diagonal elements are 1 2 and 3. These diagonal elements are eigenvalue. So it is applicable only when it is the diagonal matrix, not for other matrices. Okay. And then one more important property is there. At least one eigenvalue is 0 when it is the singular matrix. At least one of the eigenvalues is 0 if determinant of A equal to 0. That means A is a singular matrix. Okay, so you have to remember all the properties of eigenvalue and eigenvector. See, for the eigenvector, only one property is there. It is particularly for property of eigenvector. Property of eigenvector. One important property is that for the eigenvector. That property is that the eigenvectors are orthogonal in pairs. Orthogonal in pairs if A is a real symmetric matrix. Okay, is it clear now? So totally 7 properties are there. First 6 properties are for eigenvalue, last one 7th property is for that eigenvector. Okay, these things we have discussed clearly, but problems I may not be discussed inside the class for this. First we will see 1 or 2 problems in eigenvalue eigenvector, then we can solve the properties problems. First problem, find the eigenvalue and eigenvector find the eigenvalues and eigenvectors of the matrix A equal to 2 minus 2 3 1 1 1 1 3 minus 1. Is it symmetric matrix?
No, sir.
No, no. Okay. So we can write the solution for this. How can we solve it? First we have to write that the step 1, the characteristic equations. The characteristic equation is mod A minus lambda equal to 0. Otherwise we can write that some shortcut method we can use that means the characteristic equation shortcut formula is lambda cube minus a1 lambda square plus a2 lambda minus a3 equal to 0, where it is a1 is what is a1?
2.
2.
What is a1?
Sum of diagonal elements.
Of diagonal elements of A. Just I am asking the question is how much you can understand, that your understanding level I want to know that means 2 plus 1 minus 1, that is equal to 2. Second one is a2. a2 is sum of minors of diagonal elements. These steps you have to write in examination, then only can understand this step, you can understand this clearly. Okay, so what is the first diagonal element? 2 is the first diagonal element. First diagonal element you can leave that one, then for respective row and respective column, then we can have that the determinant 1 1 3 minus 1 1 1 3 minus 1. Better you can use the pencil in that examination, that will not be any doubt in this. Okay, listen, the second one diagonal element is 1, so leave that respective row, respective column. The remaining is 2 3 1 minus 1. 2 3 1 minus 1. If any doubt is there in middle to write this values, then you can ask me. The third one diagonal element is minus 1. For that minus 1, so the determinant is 2 minus 2 1 1. 2 minus 2 1 1. Now we can calculate this value. Determinant is minus 1 minus 3 minus 2 minus 3 plus 2 plus 2. So minus 2 plus 2 cancel, otherwise you can cancel this. So here 3 3 6 7 minus 5 you will get, that is the value of u2. Then you can find that the a3 is determinant of a. Determinant of a is, you can find this from the problem, that is first we can write the 2 into 1 minus 1 minus 3 plus 2 into minus 1 minus 1 plus 3 into 3 minus 1. So 2 into minus 4 minus 8 minus 2 plus 2 minus 4, and then 2 into 3 plus 6. So 12. The value is, determinant of A is minus 6. So therefore, if you are substituting the values A1, A2, A3, the characteristic equation is lambda cube minus A2 lambda square, that means minus 2 lambda square minus 5 lambda plus 6 equal to 0. Then we can solve by using that synthetic division method. So for the synthetic division method, first we have to write that the values of lambda cube here, coefficient of lambda cube, coefficient of lambda square, coefficient of lambda, and then constant value. So here, what is the coefficient of lambda cube? 1, minus 2, minus 5, plus 6. Okay, so if you are adding this, then adding all the value, you will get that 1 minus 2. In case if it is a plus b plus c plus d, already I explained in the class. In case a is 1 here, b is minus 2, c is minus 5, and then d is 6. If a plus b plus c plus d equal to 0, then 1 is a root. So now add it, it is minus 7 plus 7, so you will get that is equal to 0. So 1 is the root here. You can write, if it is not satisfied, then you can go for minus 1. Then you can, in both of them is not satisfied, mean go for 2 minus 2, 3 minus 3. This is the trial and error method, only the synthetic division method. Now we have to add this 1 plus, arbitrarily we can put 0 here, 1, but multiply that 1 and 1, you will get 1 here, then minus 2 plus 1 is minus 1 here, and then multiply that minus 1, then here minus 6 you will get, and multiply this 1 and minus 6, minus 6, so finally we will get is 0. See, compulsory you should get that value is 0, otherwise your calculation is wrong. Okay, here you have to write this power is lambda square, it is lambda, it is a constant coefficient, is it not? Therefore we can write that the reduction equation is lambda square minus lambda minus 6 equal to 0. So here multiply value is minus 6, just wait 1 minute. So when we are solving this, multiplication is minus 6, adding is minus 1. What are the two numbers? Multiplication is minus 6, adding is minus 1 is minus 3 plus 2. So we can write here lambda minus 3 and then lambda plus 2 equal to 0, lambda equal to 3 comma minus 2. Therefore the eigenvalues are, What are the eigenvalues? 1, minus 2, comma 3. Now we have to find the eigenvector. So write the heading, find eigenvectors. Find eigenvectors. So how to find the eigenvector? You have to substitute the values of each value of lambda in the characteristic polynomial. The characteristic polynomial is a minus lambda I into x equal to 0. Just wait, somebody is waiting there. Okay, now fine. So to find the eigenvectors a minus lambda into x equal to 0, how can we write this? That a minus lambda into x equal to 0, that is you have to just subtract in that with the minus lambda in the diagonal of the matrix. What is given a here? What is here? Once again write that a equal to 2 minus 2 3, 1 1 1, and then 1 3 minus 1. So how can we write that? A minus lambda I here into x, a minus lambda I into x is 2 minus lambda, just you have to subtract with that minus lambda in diagonal. x1, x2, x3 equal to 0 0 0. This is so here case 1 and lambda equal to 1 and lambda equal to 1, then substituting lambda equal to 1 here, then we will get that 1 minus 2 3 1 0 1. In case if you are substituting lambda equal to 1 here, 1 minus 1 0, then 1 0 1, and last one is 1 3. Sorry, it is minus 1 minus lambda, na? So not only that, here you have to change it, minus 1 minus lambda. So we will get that minus 2 here. Then x1 x2 x3 equal to 0 0 0. To find the eigenvalue of this, you can write that x1 x2 x3 x1 x2. Write the two non-identical rows, 1 minus 2 3 1 minus 2 1 0 1 1 0. So what is x1 here? To find that x1, leave that the respective column and write that the next two column determinant. That means minus 2 3 0 1 equal to x2. Here also you can leave that the respective column. The determinant of next two is 3 1 1 1 3 1 1 1 x3. For x3 you can leave that respective column, then 1 minus 2 1 0 1 minus 2, 1, 0. Just waiting. So here, if we are solving this, x1 by minus 2, x2 by 3 minus 1, 2, x3 by 0 plus 2. So we can get that ratio x1 equal to minus 1, 1, 1. Okay. For case 2, when lambda equal to minus 2. Substituting lambda equal to minus 2 in the matrix, the equation becomes 4 minus 2, 3, 1, 3, 1. Once again, 1, 3, 1. Okay, you have to take two non-identical rows. Here you can see that the row 2 and the row 3 are equal. Row 2, row 3 are equal. You should not take this. You should not consider this. Other then you can take that row 1 and row 2. This row 1 and row 2 are the two non-identical rows. Then we can write that x1, x2, x3, x1, x2. So here 4 minus 2, 3, 4 minus 2, 1, 3, 1, 1, 3. So to find that x1, leave this row minus 2, 3, 3, 1, minus 2, 3, 3, 1. To write the x2, leave that the particular column, the next 3, 4, 1, 1, 3, 4, 1, 1. To find the x3, leave this 4 minus 2, 1, 3. 4 minus 2, 1, 3. So therefore here we can write that x1 is minus 11, x2 is 3 minus 4 minus 1, x3 is 4, 3, 12, 12 plus 2, 14. Therefore, what is x2 here? x2 is minus 11, minus 1, 14, or 11, 1 minus 14 also you can write. Case 3, when lambda equal to 3, when lambda equal to 3, then the equation a minus lambda I into x becomes minus 1 minus 2, 3, 1 minus 2, 1, 1, 3, minus. So here x1, x2, x3 equal to 0, 0, 0. See, since here you can see that the x is, you have to substitute that values of lambda in this matrix only. So in case we are in this matrix, we are substituting lambda equal to 3, 2 minus 3, minus 1, 2, minus 2, 3 here, 1, 1 minus 3. 1 minus 3 is 2, minus 2, 1, and then 1, 3, minus 1, minus 3 is minus 4. So when you are substituting the value, you have to do very carefully. Then only you will get the correct eigenvectors. So now if you want to solve that, taking the two non-identical rows. Generally we can take that non-identical here. What are the two non-identical? Row 1, row 2 we can consider that. Okay, so we can write that x1, x2, x3, x1, x2, minus 1, minus 2, 3, minus 1, minus 2, 1, minus 2, 1, 1, minus 2. So to find that x1, leave that the respective column, then minus 2, 3, minus 2, 1 equal to x2. For x2, leave that respective column, 3 minus 1, 1, 1. Then x3 is minus 1, minus 2, 1, minus 2. So here, soon by class x1 minus 2, so minus 2, minus 2 plus 6 is plus 4, x2 by 3 plus 1 is plus 4, x3 is minus 2, sorry, plus 2 plus 2 is 4. So what is x3 here? 4, 4, 4. We taking the ratio 1, 1, 1. Okay. Therefore, so what are the eigenvalues and eigenvectors? Eigenvalues are minus 1, 1, 1, comma, minus 11, minus 1, 14, comma, 1, 1, 1 are the eigenvectors. Finally, you have to write that answer of the eigenvectors of the eigenvalues 1, minus 2, 3 respectively. So in this, what are the checkpoints are there here is you can easily verify whether your results are correct or wrong. Okay, so here you can see that the sum of the eigenvalues, that this sum of the eigenvalues are sum of the diagonal elements. So what are the eigenvalues here? Eigenvalues are, what are the eigenvalues? 1, minus 2, sorry, I'm not writing here. So we can verify here eigenvalues are 1, minus 2, 3. So 1 minus 2 plus 3 is 4 minus 2 plus 2. So this is the sum of the diagonal elements. Okay, and then second one is multiply this. If you multiply this, minus 6 you will get. Minus 6 should be the determinant of A. So lambda 1 plus lambda 2 plus lambda 3 equal to this plus 2, lambda 1 into lambda 2 into lambda 3 equal to minus 6. That should be determinant of A. If both of them is true, then only your eigenvalues are correct, and this is the checkpoint for the checkpoint or validation for your eigenvalues and eigenvectors. Even if it is a symmetric matrix, one more advantage is there, that is whether your eigenvectors are correct or wrong. By using that, the rule eigenvectors are orthogonal in pairs. See, for example, I can consider one symmetric matrix. Find the eigenvalue. This is important and simple also. Find the eigenvalues and eigenvectors of the matrix 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3. This is the matrix. Just wait. 1 minute wait. I will be. Please stay. இல்லை என்ன சொன்னாங்க? இந்த ஃபோட்டோ டவுன்லோட் பண்ணி இந்த நம்பருக்கு இதில் ஒரு நம்பர் இருக்கு, இதில் ஒரு நம்பர் கீழே இருக்கு, கீழே 8832 சம்திங் இருக்குதுல்ல, அந்த நம்பருக்கு இந்த ஃபோட்டோ டவுன்லோட் ஆகலை, என்னன்னு தெரியல பாரு. Welcome back. You can see 8 minus 6 2 8 minus 6 2 6 minus 6 7 minus 4 minus 6 7 minus 4 2 minus 4 3 2 minus 4 3. It is a symmetric matrix. Yeah, symmetric matrix. See, symmetric matrix means if you are interchanging that row to column, column to row, the values, that matrix is not changed, then that matrix is known as the symmetric matrix. You can see the solution here. The characteristic equations mod a minus lambda I equal to 0, that is, what is the shortcut formula? Lambda cube minus a1 lambda square plus a2 lambda minus a3 equal to 0. Then a1 is sum of diagonal elements that is equal to 873, that is 18. A2 is sum of minus of diagonal elements. So what are the sum of diagonal elements here? First diagonal is 8, then leave that row and column. 7 minus 4 minus 4 3, and then second one is 7 is there, second diagonal element, leave the respective column, 8 to 2 3 plus the third one diagonal element is 3, leave the respective column, then 8 minus 6 minus 6 7. Then we are solving this 21 minus 16, 24 minus 4 plus 54 minus 36. 56 now. 56 minus 36. So you will be getting that this 21 minus 16 is 5 plus 20 plus 20, 45. Then A3. A3 is determinant of A. Determinant of A is, here you can find that A there, 8 into 21 minus 16 plus 6 into minus 18 plus 8 10 plus 2 24 minus 10. So you can calculate now 8 into 5 plus 6 into minus 10 plus 2 into 10, 40 minus 60 plus 20, 0. See, we know that if determinant of A, if determinant of A is 0, one of the eigenvalues is sure. We can check it. So what is the characteristic equation? The characteristic equation is lambda cube minus A1 lambda square minus 18 lambda plus A2 18 lambda square plus A2 lambda 45 lambda minus A3 equal to 0. A3 is 0. Leave it. So therefore, if you are taking lambda outside, lambda square minus 18 lambda plus 45 equal to 0. So therefore, either lambda equal to 0 or lambda square minus 18 lambda plus 45 equal to 0. If you are solving this, lambda value is 3 and 15. So therefore, the eigenvectors are 0 3 15. Up to now we have seen that when the eigen values are not repeated, in case eigenvalues are repeated, then eigenvectors may be linearly independent or dependent. That case we will discuss. Now we see that to find the eigenvectors, find the eigenvectors. So what is to find the eigenvector? First you have to write that A minus lambda into x equal to 0. So what is A here? A is 8 minus 6 2. So here also minus 6 2 we can write, and then 7 minus 4, here also we can write minus 4, and then 3 we can write. Therefore this A minus lambda I into x 8 minus lambda minus 6 2 minus 6 7 minus lambda minus 4 2 minus 4 3 minus lambda, and then to multiply with the x1 x2 x3 equal to 0 0 0. Now we have to find the eigenvectors by substituting the eigenvalue in this equation. So sometimes we can take this as equation number 1 mean case 1 we can write substituting lambda equal to 0 in that equation number 1, we get 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3, and then x1 x2 x3 equal to, now we have to take the two non-identical rows, continuously write that x1 x2 x3 5 columns x1 x2 8 minus 6 2 8 minus 6 minus 6 7 minus 4 minus 6 7 x1 by, you leave that first row, so here 24 minus 14 x2 minus 12 plus 32 x3, so you will get that x1 by 10 10 x2 by 20 x3 by 20. So x1 is, the ratio is 1 to 2. Case 2, substituting lambda equal to 3 in that equation number 1, then we get that matrix is 5 minus 6 2 minus 6 4 minus 4 2 minus 4 0 x1 x2. So here also you can take the two non-identical rows, x1 x2 x3 x1 x2 5 minus 6 2 5 minus 6 minus 6 4 minus 4 minus 6 4. So here write that x1, leave that respective row, then we can get that minus 6 2 4 minus 4 x2, leave that respective column, not row, respective column, 2 minus 2 5 minus 4 minus 6 x3 therefore x1 by 24 minus 8 x2 minus 12 plus 20 x3 20 minus 36. So you will get that x1 by 16 x2 by 8 x3 by minus 16. So x2 is 2 1, the ratio is 2 1 minus 2. But when you are solving, what are the things you have to be very carefully do that? First thing is you have to write this equation properly. Okay, and then you have to verify after writing this. After finding this, then you have to verify the sum of the eigenvalues is sum of the diagonal elements, that means equal to a1. Okay, and then product of the eigenvalues are equal to determinant of a. You have to verify this. So after that, then finding that the eigenvector properly, and then you can check it 2 times also. There is no issue in this. So better simply don't find that eigenvalue eigenvector. You have to be check your eigenvalues and eigenvectors are correct or wrong. Okay, when lambda equal to 15, case 3 is when lambda equal to 15, the equation 1 becomes so what you get first row? First row is 15, na? 8 minus 15, 7 minus 6, 2. 7 minus 6, 2. Second one is minus 6 minus 8 minus 4. Last one is 2 minus 4 minus 12. Cos 3 is the minus 15. x1 x2 x3 0 0 0. Then take two non-identical rows. That is 7 minus 6 2, 7 minus 6 minus 6 minus 8 minus 4 minus 6 minus 8 x1 by, leave that the respective column, write that 6 minus 2 minus 8 minus 4, then x2, leave that column, 2 7 minus 4 minus 6 x3 by 7 minus 6 minus 6 minus 8. You have to carefully write this. So what is x1? 24 plus x2 minus 12 plus 28 x3 by minus 56 minus 36. 6 minus 6 8, no? What you get? x1 by Check it once again. X1 minus 6 2 minus 8 minus 4 2 7 minus 4 minus 6. Yeah, it is minus 7 na? Because 15, what is the first value? 8 minus 15 is minus 7. If you are missing that plus or minus anywhere means then you will be get wrong. Minus 6 minus 7 minus 6 2, then minus 6 minus 8 minus 4. So here minus 7 and then minus 7 should be there. So this one is, first one is corrected, but second one is here minus 7, third one is here minus 7. So 2 into 6 minus 12 minus 12 minus 28. Okay, minus 28. Then last one is plus 56 minus 36. Okay, so here it is 40 x2 by minus 40 x3 by 20. So what is the ratio? X3 equal to 2 minus 2 1, and then you have to verify that the eigenvectors are orthogonal in pairs. So what is that eigenvectors? X1 is 1 2 2, x2 equal to 2 1 minus 2. We can check it that otherwise x3 is 2 minus 2 1. So x1 transpose x2 is 1, x1 transpose x2 1 2 2 2 1 minus 2. Can check it. 2 plus 2 minus 4 0. x2 transpose x3, x2 transpose x3, x2 transpose is 2 1 minus 2, and then x3 is 2 minus 2 1, 2 minus 2 1. So that means 2 into 2 4 minus 2 minus 2 0. Last one x3 transpose x1, x1 is x3 is 2 minus 2 1, x1 is 1 2 2. Can check it. 2 minus 4 plus 2 0. So all the things should be satisfies, then only your eigenvectors are corrected. It is a very important checkpoint for you whether your eigenvectors are correct or wrong. Okay, so these two problems are
So,
fine. Yes.
should we also write this checkpoint while we are writing the answers for the exam?
Once again, can you repeat your question?
Should we write the checkpoint while we are writing the
Only,
answers?
no, that is for your verification only. In case if the
Okay, sir.
question is, if the question like that, listen, we can extend the question like that. This is the question na. Here it is a symmetric matrix, we know that. See, here I can extend the question. Prove also the eigenvectors are orthogonal. The eigenvectors are orthogonal in pairs. At that time only you have to be writing these things. No, actually it is not compulsory. It is that optional, but for that better understanding only I am telling all the things. Any other doubt is there?
No, sir, got it.
Got it? Okay.
Yes, sir.
Yes. So these problems are for that non-repeated eigenvalue. In case repeated an eigenvalue is there, then how can you solve it? For the repeated eigenvalue, how can you solve it? Okay, take now it is 11 o'clock. Take 5 minutes break. Then I will come after 5 minutes. Okay, fine.